in a nutshell, the rest of your tests will be, let's see, okay. The rest of your tests will be open book, 2 of them. The next one will cover chapters 6 and 7. Then we skip chapter 8, and the last one will cover chapters 9 and 10. You'll have a test and a mini project for this. You do them without the assistance of other human beings, although you may use your textbook and those resources, okay? But it must be turned in to me by email by the 17th, the night of the 17th, before class on the 18th, okay? And I will write you through Brightspace to remind you, but you know, that's the deal. Okay, so as I said, what I want to do first, and you're looking at my sewing room, which I've had to use a lot recently because I've been having to use a lot of masks. I've been making masks left and right. It's insane. Okay, so what I want to do is kind of go over what we had done the last time we met, 7-1, about writing the null and alternative hypotheses. And to do that, I'm going to go and do some problems in Pearson from that section. Okay, so let's see. Oops. I need to get there and then share my screen with you guys. Come on. Sorry, there's always a delay. So I may be talking about something which you can't see yet, but you'll be able to see it. Okay, let me make sure that everybody's in. Okay. All right, so I'm just going to randomly start this at say question 2. If it'll come up. There we go. Okay, can everybody see my screen?
Yes.
Okay.
Yes.
All right, so you recall that what you have to do first is read the problem and then write symbolically what the claim says. So here is the symbolic representation of this claim. It says P, which is proportion, is less than 0.21.
We're not seeing the question.
You can't see this? Oh, well, that sucks. Okay, well, I'll tell you what. I'll put the question here. I'll have to toggle back and forth, but I'll put the question on the IPVO. So I'll change the share to the IPVO, which of course is a pain. All right, so what this says is that symbolically the claim was proportion is less than 0.21. And then it asks you for the complement. Now, when we did this in class last time, we actually called this the if-false statement. What would have to be true if this was not true? So this is the claim. So what would have to be true here? If P is not less than 0.21, what is P? You guys can talk.
More than 2.21?
Yeah, more than, greater than, but also it could be equal to. You see what I mean?
Yes.
Okay, if P is not less than 0.21, then it is either greater than 0.21 or equal to 0.21. And this is how you write that symbolically. Okay? So the null hypothesis is the statement that has equality in it. So this thing, the if-false statement, becomes the null hypothesis. And that means that the claim becomes the alternative hypothesis. Okay? And as I said last time we met, it's incredibly important that you get this right, because if you don't get it right, then you will miss probably 3/4 of the whole hypothesis test, because the hypothesis test is based upon this, what the alternative hypothesis is. Because when you have an alternative hypothesis that has the inequality to the left, the less than symbol, then that is a left-tailed test. And when you're doing this in StatCrunch, you have to identify the direction of the alternative hypothesis. So if you fail to get this thing right, then you'll miss most hypothesis tests, most elements of it. Okay, so I can't overemphasize how important this is. Okay, so let's do a different one. I'm just gonna, you probably won't be able to see this, but I'm just gonna go to number 3, okay? So number 3 says this, and I'll go back on. It says, if the null hypothesis is P not equal to 0.3 and the alternative hypothesis is P, and whoops, sorry, the null is P equals and the alternative P not equal to 0.3. What kind of test is this? Okay, this is incredibly important that you know this. So let me show you this. And if you weren't here, like Pam wasn't, or if you were here and you've forgotten, you ought to take a picture of this, because this is the rule about the type of test it is based upon the symbol that appears in the alternative hypothesis. So when the alternative hypothesis says not equal to, it's a two-tailed test. And that means that you have a critical region on either side of the bell-shaped curve. One of the things that I sent you in the email was this piece of paper, right? And when we get to doing these tests in a few minutes, I'll be using this worksheet paper. And I suggest that you use it when you do your homework, because it gives this little section for going through the steps of writing the null and alternative hypothesis. Then it leaves you an area for writing the stuff from the sample. And over here, it leaves you an area for putting in the results of the hypothesis test, including your decision and your conclusion statement. So it's a handy way to keep track of running a hypothesis test. Okay, so the next problem in Pearson says, if I know that the claim is mean is less than 0.25, okay, which is how you would write that. This is the claim. It asks, what is the null and alternative hypothesis? Okay, so again, the first thing you have to do is write the if false statement. And your book calls this the complement statement. So what would have to be true if the claim was not true? Sorry about the focus. It tries to refocus every time I put my hand in there to write. So there you go. That's not really in a lot better focus. Ugh, it's awful. Okay, that should be better, okay? All right, so if the mean is not less than 0.25, what is it?
More than or
Come
equal to.
on, you guys can talk. It's what?
Greater than or equal to?
Sure. 0.25. All right. So which one of these two statements becomes the null hypothesis?
The if false statement.
Yeah. Because the null hypothesis is the one that contains equality. And that leaves the claim to become the alternative hypothesis, which makes this a left-tailed test. Okay, and again, if you are working with that worksheet paper, that means that there's a critical region only on the left-hand side of the bell-shaped curve. Okay? Okay, let's do one more and then we're gonna go to the rest of the chapter. Okay, so what if the claim said that you wanted to determine whether the claim is that the mean, let's say we were talking about tires, that the mean number of miles that these tires that this person is trying to sell will be good is at least 50,000 miles. Okay, what does at least mean?
Greater than or equal to?
Right. So when somebody says that those tires will last at least 50,000 miles, they're meaning, and I'm sorry, I don't have the chat open, so I can't see it on this screen. So if you're chatting, I'll get to you in a minute. At least means that it will go to 50,000 miles at a minimum, or perhaps more than that 50,000 miles. So greater than or equal to 50,000 miles. Okay, then what would the if false statement be?
Thousand miles,
It'd be what?
less than 50,000 miles.
Exactly. So less than 50,000 miles. And so the null hypothesis, which one becomes the null hypothesis?
Less than 50,000.
No,
No,
the
greater.
claim has to become the null hypothesis, because the one that becomes the null hypothesis is the one that contained the possibility of equal. Okay, so this is the only one that contains the equal sign, and that leaves the alternative hypothesis to come from the if false statement, and that makes this a left-tailed claim. Now, what I want to point out to you about that is that these two things show you that the null doesn't always come from if false, or doesn't always come from the claim. You need to go through this, because sometimes the claim becomes the null hypothesis and sometimes the claim becomes the alternative hypothesis. So you need to go through this system every time, because again, you'll see when we use StatCrunch that the way StatCrunch runs, you have to get the alternative hypothesis right. And if you don't, you'll be potentially screwing up maybe 75% of your test, including the conclusion. So it's really important to get this right. And if you haven't done these problems in section 7.1, you really, really, really need to do them. And P.S. about the problems. As I say, I will send you the test in the middle of this week. it is due before the next actual class section on the 18th. And what I ask you to do is to do all the rest of the homework problems in chapter 7 before that, which means on the 18th after class, I will go write down a score like I always have, as if you took the test on the 18th. And a whole bunch of you guys need to get this homework thing in line because it is dropping your grade significantly. Okay, let me go back then and make sure. Okay, thank you for people that are chatting. Sorry that I'm missing you, but that's kind of inevitable. All right, so I'm going to do most of, I'm going to see if I can make this a little bit bigger. Does that help? It means I can't see anything except this screen, so I can't see any of the chat line from here, but that'll be all right. What I'm going to do mostly is problems directly out of the textbook, because if we do a few of them, I think you'll get the gist how this thing is done. So I want to remind you that when you're working in StatCrunch, if the test is a proportions test use Z distributions, and in StatCrunch, that's a section that's called proportion stats. And if it's a test around a mean, then that uses a T distribution. We talked about this last time we met. The T distribution is very similar to the Z distribution, except that, and I believe it's table 5 in your little you know, section of tables. The difference is that T distributions are more useful when sample sizes are small, because they still are bell-shaped, but they change slightly in order to accommodate smaller sample sizes. To be safe, we always use a T distribution for any test around a mean. And in StatCrunch, that is under this thing that's called T-stats, okay? And there are rare occasions where you could use a Z distribution for a means test, but that actually, we skipped that section. That would have been section 7.2. We skipped it because you can only use a Z distribution for a means test if you know the standard deviation of the underlying population, which typically you do not know. A T distribution is just better here. So just memorize this. If I'm doing a proportions problem, I'm using this thing called proportion stats, which is a Z distribution. If I am doing a means test, I'm always going to be using a T distribution, and that's T-stats, okay? And again, if you weren't here last you know, time, or if you'd forgotten, it'd be a good thing to take a picture of this little admonition here. Okay, so let's start out by doing example 4, which is on page 380 in your textbook, okay? And I'm just going to read it to you. I know that you probably don't have your text up in Pearson right now, and I don't believe that it's worthwhile for you to go get it. I think that it would be a waste of your time. So I'm going to read it to you. It says a used car dealer says that the mean price of used cars sold in the last 12 months is at least $21,000. Okay, so that's their claim. So he's talking about mean. So the symbol is mu. The word at least means greater than or equal to. And he's claiming that the mean cost of used cars in the last 12 months was $21,000 or more. So to fill this thing out, the if false statement would be
Are you writing
mean is
something?
less than 20. I am. Can you not see my Pivo screen?
No, we see you.
Yeah, it's not showing.
Okay. Okay, thank you. Sorry. Let me share the Pivo. All right. Thank you. Because remember, I can see what I can see, right? Now can you see it?
Yes.
Yes.
Okay, good. All right. So is it better if I have it big like this?
Yes.
Yes.
All right. So this is the claim that the mean price of the used cars over the last 12 months is at least $21,000. Then that makes the if false statement mu is less than 21,000. So the claim becomes the null hypothesis because it has equal in it. And that means that the if false statement becomes the alternative hypothesis. And that makes this a left-tailed test. Okay, so I know that there's some critical region on the left. Now, we're going to be using StatCrunch to do these tests, which means that functionally, you're not going to be using the traditional method. But I will remind you that in the traditional method, when you calculate a test statistic, if the test statistic falls in a critical region, then you reject the null hypothesis. And if the test statistic doesn't fall in that critical region, then you fail to reject the null hypothesis. We talked about this last time we met too. And again, if you have forgotten or if you weren't there, you should take a picture of this. You will mostly be using the p-value method that StatCrunch supports, okay? Which means you will be determining this thing called a p-value. It's listed in the results from StatCrunch. And if the p-value is less than the significance level, which is alpha, then you reject the null hypothesis. If the p-value is greater than the significance level, then you fail to reject the null hypothesis. In reality, these two things mean exactly the same thing, but because we're using this statistical instrument, StatCrunch, we're mostly going to be using this p-value idea. Okay, so back to this problem. Here's what the data says. You took a random sample of 14 used cars and found that they had a mean price of $19,189 with a standard deviation of $2,950. So I'm going to write all that down. Your N was 14, so that's your number in the sample. X bar, the sample's mean, was 19,189, and the standard deviation of the sample, that's S, is 2,950. Whoops, should write that right. 2,950. And it asks, is there enough evidence to reject the dealer's claim at a significance level alpha equals 0.05? Okay, now I want to remind you from last time that the significance level is the size of this rejection region. Okay, and actually we talked briefly about the fact that that creates this thing called a critical value right here, and I'm not going to emphasize that because we're using the p-value method. I'm not going to emphasize that, but it's whatever value of a z distribution or a t distribution that leaves 0.05 as an area to the left. Okay, so now that we know this information, if we were doing it using the, June. If we were doing this problem using the traditional method, what we would do is now calculate this thing called the test statistic. I'm going to show you the formula for the means test statistic. And I'm not going to do it because we're going to use StatCrunch, okay? But that would be the next step if we were using the traditional method. It turns out that StatCrunch is going to give us this value anyway, okay? So the next thing we're going to do is go to StatCrunch, all right? So make sure that you have put down this information, whether you're using just a blank sheet of paper or you're using this worksheet paper, it doesn't matter. So I'm going to change the share to StatCrunch here. It's going to take me a second to do that. Here's StatCrunch. Okay, wait, I've got to find it because it does not seem to want to find it. Let's try this. Okay. What? Okay, can you guys see the StatCrunch window now?
Yes.
Yes.
Okay.
Yes.
All right. Sorry it takes a bit. Okay, whoever's, if you're on a phone or something, you're getting an echo. It probably is you, June, since you just came in.
I'm on my Chrome thing, my
Okay,
Chromebook.
somebody has set up a system where it's reverbing, where it's echoing me. So try muting your mics and see. Okay. Well, it's not doing it now. So whoever, thank you, whoever it was. All right. So we have this information. This is a means problem. So we're going to go to stat, and then we're going to go down to T-stats. As I said last time we met, whenever you're doing a means problem, you're using T-stats. Then you're going to go over to one sample and then all the way over to with summary. Click it. And this box comes up. Now, sadly, I don't think I can make this box bigger. I mean, I can make it bigger, but it doesn't change the size of the top. So hopefully you're working along with me here. So it asks, what is the sample mean? And so that was the 19,189. What is the sample standard deviation? That was the 2,950. What is the sample size? That was 14. And then you want to, you're going into a section that's labeled perform. And so you are performing a hypothesis test, which is the default position. But you need to tell it what the mean is in the null hypothesis. So you need to put in there 21,000. And then in the next one down, the next line down, you have to identify the alternative hypothesis. In this case, it is less than. If you fail to match this thing up with the correct alternative hypothesis, it'll still blab out results. They'll just be wrong. Okay, so once you've got that filled in, you hit compute. And here are the results. Now, you probably can't actually read my screen, but this one right here tells you the test statistic. So it was negative 2.2969971. So I'll just say negative 2.30. I'm rounding it to 2 decimal places. It also tells you that the p-value, that's the last one in that line, is 0.0194. Okay, now I'm going to change the share back to my PIVO. Okay, can you all see the IPIVO now?
Yes.
Okay.
Yes.
All right. So what this tells you is that your p-value is 0.0194, and you compare your p-value at 0.0194 with your significance level at 0.0500. Now notice that I have changed the significance level. I haven't actually changed it, but I've added 2 zeros. The reason I've added these 2 zeros is for some people it is hard to compare 2 decimal numbers unless they are the same length, okay? So if they're the same length and now they're both 4 decimals long, then you can simply just ignore the decimal place and just read 194 over here and 500 over here. This p-value is less than the alpha value. And when the p-value is less than the alpha value, your decision is to reject the null hypothesis. That is fundamental. But also it means that this test statistic must have been in the critical region. If we had done it using the traditional method, we would have found that to be true. Okay. So we now know that our decision is to reject the null hypothesis, and what we have to do is write our conclusion statement. Now here's the thing about writing the conclusion statement. You have to know whether or not the null hypothesis came from the claim or the alternative, and you have to know whether or not you rejected the null hypothesis, okay? So here in this problem, the claim became the null hypothesis. Do you see that? And we rejected the null hypothesis. This box, this text box is actually on page 356 of in your text, but here it is. And if you don't already have this in your notes, let me fold that better. If you don't already have this in your notes, then you should take a picture of it right here, okay? So in our case, the claim did become the null hypothesis, and we rejected the null hypothesis, so the wording we want to use is right here, which says there is enough evidence to reject the claim that, and then you have these dots, okay? So what you do is you write out the wording, and then you fill in the dots what the claim actually was. So for our case, that would be there is enough evidence to reject the claim that the mean is at least $21,000. Okay? All right. So, P.S. there are handouts in the course content in D2L about how to run these tests. And I gave them to you in class last time, but they're also in the course content if you've misplaced them. So this actually is just an example like we just did, this one for the mean. All right, so let's do a couple of other problems. All right, so I'm doing problems out of your text primarily because you can go back and you can look at the way they solved the problem in the text, which they all do with the traditional method, okay? But you can see that it turns out the same way either way. Okay, so I'm going to do problem, let's see, the problem on page, sorry, 389. Okay, it's a proportions problem. Okay, so it's on page 389 if you want to look it up later. All right, so what it says is this. And let me make this bigger again. Okay, so it says a researcher claims that less than 45% of US adults use passwords that are less secure because complicated ones are too hard to remember. So he's claiming that less than 45% of people use easy passwords. Okay. So as soon as I see 45%, I know this is a proportions problem, because remember that proportions, the problems usually either tell you a decimal value or a percentage value. Okay, so what he's claiming then is a proportion, so the symbol is P, is less than 45%. Normally we will change this to a decimal number in writing the null hypothesis. So 45% is 0.45. All right, if that is not true, then the proportion is greater than or equal to 0.45, right? Because that's everything else. That means that the if false statement here becomes the null hypothesis because it's the statement that has equality in it. And that leaves the claim to become the alternative hypothesis. Again, this is a left-tailed test. So it leaves a critical region on the left. Now here's what we know about the sample. In a random sample of 100 adults, so N equals 100, 41% say they use easy passwords. So P hat, remember that's the proportion in the sample, is equal to 41%, which is 0.41. At a alpha level, a significance level of 0.01, is there enough evidence to support the researcher's claim that less than 45% use easy passwords? Now, the problem here turns out to be when you use StatCrunch, it doesn't ask you for P hat. It asks you for the actual number of people in the sample who gave that reply. So to do that, you need to remember that P hat is X divided by N. And if we change that around to solve for the number who gave a specific response, then X is equal to P hat times N. Therefore, the number who said they use easy passwords is actually 0.41 times 100, which is 41 people. Now that turns out that math was easy because the sample size was 100, which means that the X came out to be a whole number in the first place. But I remind you that X values have to be whole numbers when you put them into StatCrunch. So if you got something like 40.25, okay, then you round it to the nearest whole number and it'd be 40, okay? So now we're ready to take this to StatCrunch. And again, I gave you last time we met a handout about running a hypothesis test for proportion. Pam, I think you were the only one that wasn't there. And this is in the course content in Brightspace.
Okay.
Okay. Okay, so what we want to do, I need to change the share back to StatCrunch now. So give me a second to do that. Okay, so about now you should be seeing StatCrunch again. Okay, so to do a proportions test, we go to Stat, but we want to choose the one that says Proportion Stat. It is one sample. We are working with a summary. So we click that, and this is the window that pops up. And the first thing it asked me for is number of successes. That's X. The number of people who gave a specific reply. In this case, the number of people who said they use easy passwords because complicated ones are too hard to remember. Okay, so that's 41. Then you need to fill in the number in the sample. So it says number of observations. So sample size was 100. Then you go down to perform. It already is clicked on hypothesis test. And so the proportion in the hypothesis statement was 0.45. And then you have to choose the direction of the test. So that's the alternative hypothesis. In this case, it was less than. Once you do those 4 things, you're ready to hit compute. So the answer box comes up, and the answer box tells you several things, but the 2 you want are these 2 on the far right-hand side. So the first one is the size of the test statistic. So that is negative 0.804. And then the p-value is 0.2107. Okay, so now I'm going to go back to my Pivo screen. I know it's sort of disconnected the way we have to do this, but it works pretty well. Okay, so there you go. Here's the iPivo screen, and so I've filled in the 2 things that we now know from the results of the StatCrunch thing, okay? And again, when you use StatCrunch, you're going to make a comparison between the p-value and the significance level. So in this case, I'm just going to erase what we had up here and use this area again. The p-value was 0.2107, okay? The alpha value from the problem was 0.0100. I'm adding those 2 zeros in order to make sure, should have erased this too, in order to make sure that they're the same length. So now you should be able to see that the p-value is a lot larger than the alpha value here. That's a bigger decimal number. And when the p-value is greater than alpha, my decision is to fail to reject the null hypothesis. Again, this is based on this idea here, okay? So if you didn't write this down or you didn't take a picture of it, here's another opportunity for that. Okay? So the last thing we need to do is write the conclusion statement. And to write the conclusion statement, again, we have to know what the claim became. And so in this case, the claim became the alternative hypothesis. That means that in our statement table, we're using this column. And then the other thing you have to know is what was your actual decision? Well, our decision was to fail to reject the null hypothesis. So in this case, we're using that section where the claim is the alternative and the decision is to fail to reject. Okay, and again, we start out by simply writing the words that are in the box, and then when you get to the ... you restate the claim. Okay, in words, not in symbols. Okay, so I would state that there is not enough evidence to support the claim that the proportion who use easy passwords, yeah, I know, I didn't leave myself enough room here, is less than 45%. Okay? And you can, again, this was a problem that was on page 389. You are welcome to look at that problem. So I'm gonna do one more, and then I'm gonna go to the capstone piece for today. Okay, now I understand that we're not going to end up using all of our time, which probably we would have had we been in class on campus. But that is mostly because on campus I would be able to use the PowerPoint slides, but I'm not, you know, shortcutting you here at all. You're really getting everything, because the meat of these two sections is how to do these problems. All right. So I would remind you that and you should try to do some of these problems over the weekend. And if you have trouble, we are now virtually tutoring Sunday through Thursday night, 6:30 to 8:30. The link is in the Bright Space content. And I'm the virtual tutor on Monday night. So if you have issues, you know, you should get on that tutoring site one of those days, preferably Monday, but one of those days, to clarify how to do these problems in 7, 3, and 4. Okay, so one more problem. I'm going to do the problem that's on page 390. So it says researchers claim that 51% of adults believe that antibiotics are effective against viruses. Okay, so to write that claim, again, I see a percent, so I know this is a proportions test. So the symbol is P, and it says claims that literally 51%. So that means the proportion they're claiming is actually equal to 51%. And we write 51% as 0.51. Okay, if that's not true, what would have to be true?
He is not equal to 51 to 0.51.
Exactly, that's correct. And when you have this, then the one that contains equality is the one that just says equals. Okay, so I always have somebody that argues with me that because they can see an equal sign in the equal slash thing, they're not equal to, then it also contains equality. No, it's the exact opposite of equality, okay? So here the claim became the null, and the if false became the alternative. And when there's the symbol for not equal to in the alternative hypothesis, that makes this a two-tailed test, which means that there's two critical regions, one on the left and one on the right. Okay, so what we know is that they took a random sample of 2,202 adults. So N was 2,202. And that 1,161 of them said that they thought viruses were effective, antibiotics were effective against viruses. So here you're lucky, they are telling you the X value. At a significance level of 0.10, so they're telling you that the significance level here is 0.10. Is there enough evidence to support the claim that the actual proportion of US adults who believe that antibiotics are effective against viruses is 51%? Okay. So again, you're doing a proportions test. So I'm going to go back to StatCrunch. I'm going to change the share so that you can see the StatCrunch window. Okay, so can everybody see StatCrunch now?
Yes.
Okay, let me do something because did somebody else come in? Okay, no, let's see. Sorry. All right, so we're going to go to stat, then down to proportion stats, one sample with a summary. The number of successes was 1,161. Remember, that's the number of people who said that antibiotics are effective against viruses. And that's out of a sample size of 2,202. The null hypothesis proportion was 0.51, so that needs to be changed. And then the alternative is not equal to. Now, that's the default position, so I don't need to change this. It's already a two-tailed test. That's the default one. So I just hit compute. And so now the results are a test statistic, the z-stat at 1.619, when the p-value is 0.1054. Okay, so now I'm going to go back to the IPVO screen. Okay, and so again, we're using the p-value method, so I'm going to compare the p-value with the alpha value. So in this case, the p-value was 0.1054. The alpha value is 0.1000. So here the p-value is greater than the alpha value, and that means that I failed to reject the null hypothesis. All right, and then when I write my statement, the claim became the null, which means I'm in this column here. And we failed to reject the null hypothesis, so this time we want this one. All right, so I would say there is not enough evidence to reject the claim that the proportion is 51%. Okay, now folks, I get that there's a lot of steps to this thing, but I'm going to tell you that this is not that hard if you practice it a few dozen times. Okay, and that's why I sent you the little template for making your own little worksheet things here, right? And that's why I think you should, you know, try these problems in Pearson and make sure you can do them. And if you can't, get some tutoring aid, because there's a lot of steps to this thing, but it's not impossible to do. It's just not. And again, I have used problems that are in your textbook. So if you don't understand, I mean, say 2 or 3 days goes by and you don't know, you don't remember what we did, all right? You can go back in your textbook and look at exactly the same problems that I just did. Okay, so what do you think? Do I need to do another, or are you pretty good and can we go on to the capstone piece? What do you think? Are we okay to go on? Okay, let me look at the chat. I can't. Unfortunately, I cannot seem to keep every single one of these balls in the air at the same time. All right, let me look at the chat. I do not know why I can't seem to get the chat thing to come up, but let's see. Okay, so everybody seems to think they're okay. Honest to goodness, folks, this is a matter of practice. So please practice. All right, that's what I would tell you. All right, so I've got to go back to the IPVO to show you the capstone. I did not send, well, I might have. Did I send this to you?
Yes.
Okay. So if we were in class together, I would actually make you do this first thing, which says open the data set labeled time deviations, global temperature deviations, sorry. Use StatCrunch to create a bar chart timeline. However, because we do not have that luxury, I actually sent you a bar chart. Okay, so everybody should be able to open this in Word and insert the bar chart that I sent you right here. It looks like this. Let me see if I can get that as. Now, in the one that I have here, I have actually drawn a line that helps you identify the 10 years where the deviation was the highest, okay? So think of this as the global temperatures were the highest from a normal deviation of 0 year to year, okay? So hottest years is what this actually is. If you had done this in StatCrunch, as we would have done if we had been working on this together in class, then this bar chart would have been interactive and you could have determined the years, all right? And notice that there's two that are down here. This actually goes from, I think, 1934. No, it's a little more than, like 1900 to present day, okay? So there's two that are down here, but most of the hottest years are over here. And this is actually in the 2000s, all right? So again, if we had been working together in class, I would have made you identify those years and the size of the deviation. But because we're not, I'm going to tell you what they were. And you need to now put this into either your blank one that you're working off of if you're just writing them in, or if you have it open on the desktop, you know, you could put it into the Word document now. But here's what they were. And I've done it by largest deviation down to smallest deviation. But the hottest year was 2012. Where the deviation was 3.26 degrees Fahrenheit hotter than previously recorded years. In 2015, it was 2.38. In 2006, it was 2.23. In 1998, it was 2.21. In 1934, it was 2.08. In 1999, it was 1.586. In 1921, it was 1.78. In 2001, it was 1.68. In 2007, it was 1.63. And in 2005, it was 1.62. Again, you could take a picture of this right now if you need to get the information for later. Okay.
Hold on one second.
So, whoops, you need it back. There you go.
There we go.
Can I take it away?
Yes.
Can I take it away now? Okay.
Yes.
All right. All right. So it asks how many of the 10 years with the most deviation in the last 115 years occurred in the 2000s. So how many were there?
6.
Yeah. So 6 out of the hottest 10 years occurred in the 2000s. What does that suggest about global temperatures? This isn't a trick question.
They're getting
If
hotter.
6 of the hottest 10 years have occurred, yeah, at a greater rate. It's getting hotter faster. That's a reasonable thing to say. Now, that is a observation based on a chart, which is useful, but it's not as meaningful as performing a hypothesis test about this. So the second task says to test the conclusion reached in task 1. We can perform a hypothesis test to compare the deviation in the 2000s with the deviation in the 1900s. So what we're doing is we're comparing the deviation in the last 15 years. This data only goes through 2015. We're comparing that with the deviation in the entire century of the 1900s. So what I did the work for you, and I found that the mean deviation in the 2000s so far has been 1.328, while the deviation in global temperatures in the 1900s was actually negative. It was negative 0.012. And you're asked to test the claim that the mean temperature deviation in the 2000s is higher, which means greater than, doesn't it, than the mean temperature deviation at negative 0.012 with a significance level of 0.05. Okay, so the claim is that the mean temperature deviation, so the symbol is mu, is higher than, which means greater than, negative 0.012. So if that is not true, then the mean is less than or equal to negative 0.012. So the null hypothesis comes from the if false statement, mean less than or equal to negative 0.012, and the claim becomes the alternative hypothesis, mu greater than negative 0.012. Okay, so here's our data. Of the 15 years in the 2000, I told you that the mean deviation is 1.328. Now, what I failed to tell you was the standard deviation, but I know what it was. So n is equal to 15, right? Standard deviation for the, I'm going to actually give it to you like this. Standard deviation, whoops, should be considered to be 0.2015. Okay, and the alpha level is 0.05. Now this is a right-tailed test, right? Because the alternative hypothesis is greater than. Okay, so now we can go to StatCrunch. And this is a means test. So I'm going to change the screen to StatCrunch. Okay, so everybody can see StatCrunch now, right?
Yes.
Okay. So I go to Stat, and then I'm going to go down to T-Stats, because remember, when we're doing a means test, we're using a T-distribution. Then I'm going to go to one sample with a summary. And here's my box. It asks me, what is the sample's mean? 1.328. What is the sample standard deviation? 0.2015. What is the sample size? 15. It's a hypothesis test where the mean in the hypothesis is negative 0.012. okay? And then the alternative hypothesis is greater than. Okay, so you got to get all that in there and hit compute. And here is my test result. Okay. My test statistic is at 25.76 with a p-value which is less than 0.0001. Okay. So now I'm going to go back to my Pivo screen. So now I think without even writing it down, it is clear that this p-value is much smaller than this alpha value, which means we would reject the null hypothesis. Okay, and so in writing the decision or conclusion statement here, the claim became the alternative hypothesis. See, claim became alternative, and our decision was to reject. So that's this box here, right? If I can get that all in there. Claim was the alternative, and we rejected. So that means we have to write it like this. So we say there is enough evidence to support the claim. That the mean temperature deviation in the 2000s is greater than that in the 1900s. Okay, so functionally, the difference between task 1 and task 2 is simply that in task 1, we were using our own judgment and an observation and saying, hey, you know, if 6 of the hottest 10 years are here around the 2000, man, it seems like global temperatures are rising. Yeah, that's a good observation, but it's not statistical proof. This other thing here that we did in task 2 is actually statistical proof. We have literally developed the actual numbers and done a formal hypothesis test to prove that there's enough evidence to support the conclusion, statistical proof, that the mean deviation in the 2000s is actually greater than that in the 1900s. And in task 3, that's essentially what they're asking you. Task 3 just says, how does the result of task 2 compare to task 1? Well, you reach the same conclusion that it's getting hotter in the 2000s than it was in the 1900s. But which is the more valid proof? A formal hypothesis test is always the more valid proof. Okay?
What was the answer to the last question again?
Well, it asks which procedure, the comparison using the graph or the formal hypothesis proof is more valid. What do you think, Pam?
Which percent?
Huh?
The The hypothesis test?
Yes,
Okay.
because it doesn't rely on judgment. That's the difference. Whenever you're just comparing a picture or something, you're using your own judgment to say, you know, yeah, it looks like, right?
Mhm.
When you're using a formal hypothesis test, you're actually forcing yourself to look at the concrete evidence, right? So in this case, you were looking at the actual average global temperature deviation in the 2000s and comparing it using a formal test with the temperature deviation in the 1900s. That is much more valid proof of the idea.
Okay.
Okay, so folks, that's a summary of the rest of the chapter and the capstone. So a few little things. One, on the capstone, what I need you to do is finish it up in Word, okay, and send that to me. Okay, that's how you're going to turn in your capstone. P.S. If you have other older capstones that are still due that you haven't turned in to me, you need to email those to me as well. Okay? And you should have those. Now, if you have left them in your H drive, you've got a real problem because you can't reach your H drive unless you're on campus. Okay? Is there anybody in that situation? Okay, nobody said they were. Okay, that's good, because that would have been a problem. So again, I need to receive all of those capstone pieces before the end of the semester, okay? So think about that. You do not want your grade to end up being lower simply because you didn't turn in a capstone, which we are all doing together, right? So that's one thing. The second thing is, again, a reminder, and good, June's here now and can hear the reminder. I am sending you the test for chapter 6 and 7 during this week. It will be an open book test, which means you can use your textbook, you can use any other resources that Pearson offers you or whatever. What you cannot use, you are not allowed to consult other students, and you are not allowed to ask tutors for help with the test or with the little mini project thing that you will get along with the test. You will, however, have several days to work on it because it isn't due to be returned to me until the 18th, which is the next time we meet. Okay, next week, that weekend we have off for Easter. Okay, but we meet again on the 18th. I also will remind you that I am virtual tutoring. There are virtual tutors now for this course, Sunday night through Thursday night. My night is Mondays, and that's from 6:30 to 8:30 in the evening. So let's say you go and do the homework, which you should this weekend on these sections in chapter 7, and you have questions about that, okay? Then you could get on virtual tutoring and ask your question. Then you get the test, and there's some in the test that you're having issues with. You can't ask about specific questions on the test, but what you can do is find examples in, say, the textbook, which are a lot like your problem, and ask about them to the virtual tutors. You understand? I mean, there are ways to talk about, the other. Okay, June, we'll just have to try to figure out what to do. I mean, there are other students that have their capstones that are not, I think, ask some of the other students, maybe you can consult with them. I don't even have a way to get your capstones. I can see my own, I actually can see my own H drive from home, but I can't see anyone else's. So, you know, you need to work out this issue by talking to other students in the class. Maybe you can share some stuff in the discussion area of Brightspace, right? You have all the capstones because they're all in Brightspace, but you may have to redo a bunch of them because you don't have access to the repository at school right now. I don't think they're actually letting anybody to speak of into the campus, but you could ask, you could contact the people at Magnolia and see whether you could be allowed in briefly to open your H drive and print stuff out. That's my only other suggestion. Sorry that it's an issue, but none of us knew this was going to happen. Okay. You can scan them and send them via email, or you don't need to upload them. Miranda asked if they should be uploaded to D2L. No, I don't think that's necessary. You can just scan them, or if you've got them as a Word document, just attach them as an attachment to email and just send them to me. Okay, all right. So the only other issue before I let you guys go is this. Most of you are in the 0530 as well. I want to remind you that what you need to do in the 0530 is complete the labs and do the review quizzes and get at least an 80% on the review quiz, okay? If you get 80s or above on all the review quizzes, I'll count it as if it were the proficiency exam. Okay, everybody understand?
Yes.
All right then. Okay, it's been interesting. I have made a recording of this that will be available. I'm going to try to get a hold of Ricky, who apparently, she's probably way overworked right now, but wasn't here. So, if there's no other questions, then I'll end the meeting and thank you guys for putting up with all this. And I'll see you on the 18th and hear from you before that.
Can somebody help me with the capstone in chapter 6? This is Pam.
You know, my suggestion, Pam, is that you use the virtual tutors to come in and help you with that as well.
Okay.
But, you know, you're welcome to get together with the other students on that. Okay?
Alrighty, thank you.
I'd go through the discussion boards in Brightspace. It's easier to exchange information there.
Okay.
Okay? All right.
Thank you.
Bye.